Lesson 1.6, Least Common Multiple. In this lesson, you will identify common multiples and then find least common multiples. Multiples that are shared by two or more numbers are called common multiples, just as factors that were shared by two or more numbers in our last lesson were called common factors. The least of the common multiples is called the least common multiple, LCM. You can find the LCM of two or more numbers by listing multiples or using prime factors. In this first example, example 1, we're going to find the least common multiple using lists of multiples. We are asked to find the least common multiple of 4 and 6. I'll start with listing multiples of 4. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. 6 times 4 is 24. 7 times 4 is 28. And we could go on and on and on, simply by multiplying 4 by the next whole number. Similarly with 6, 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. 7 times 6 is 42. And again, we could go on and on and on, simply by multiplying by the next whole number. As in greatest common factor, after we made the list, we went back and circled the numbers that were common. Since we're looking for the least common multiple, again, we're going to circle numbers that are common. So I see 2 12s. And I see 2 24s. And that's as far as I went with common multiples. So the least is the smallest of these. So the least common multiple of 4 and 6 would be 12. Example 2, finding the least common multiple using prime factorizations. We're asked to find the least common multiple of 16 and 20 by making a factor tree for each number. That's how we start. With 16, I will do 2 times 8. 2 is already prime, 8 is composite. I'll break that down into 2 times 4. Again, the 2 is prime. 4 I can break down into 2 times 2. And now I have all prime numbers. 2 times 2 times 2 times 2, or 2 to the 4th, for 16. For 20, I will break that down into 4 times 5. 5 is prime. 4 again is composite, and I can change that to 2 times 2. Now I have only prime numbers for my factor tree for 20. The next step is to list the prime factorization. So for 16, it was 2 times 2 times 2 times 2. And for 20, it was 5 times 2 times 2. This next step is a little bit different from greatest common factors, so listen very closely. I'm looking at the common factors first, and I see that there are 2's in both 16 and 20. What I need to do is look where there are more 2's. There are more 2's. It appears more often in the factor list for 16. So I'm going to circle all of the 2's that were in 16 because they occurred the most often. 5 appears only once, so I will circle that, but I will not circle the extra 2's again. And then I find the product of those numbers that I have circled. So 2 times 2 times 2 times 2 times 5. When I multiply all that together, since order doesn't matter, I have 10, and I have 2 times 2, which is 4, times 2 more is 8, and 8 times 10 is 80. So the least common multiple of 16 and 20 is 80. Again, the tricky part with this is remembering with least common multiple, you find the number that is common to both numbers and circle all of the ones in the row that they occur the most often. So because there were 4 2's for 16 and only 2 2's for 20, we circled those 4 2's. And then there's only a 5 in 20, so that has to be the most often because it's the only one there is. So circling that 5 and then finding the product of those circled numbers will give us the least common multiple. Example 3, finding the least common multiple of 3 numbers. We could do this one of 2 ways. We could list the multiples for 4, for 15, and 18, and then circle the ones that were common and choose the smallest number. Or we can do the factor trees and use prime factorization. Let's do that second method this time. So I'm going to make a factor tree for each of these numbers. For 4, I'll do 2 and 2. That's simple. Those are both prime. So 2 times 2 is the prime factorization for 4. For 15, I can do 5 and 3. Again, those are both prime numbers. So those are the factor pairs for prime factorization for 15. For 18, I'll do 2 times 9. 2 is prime, 9 is composite. It's a perfect square. I'll factor that into 3 times 3, and those are prime. So there are my prime factorizations for each of those numbers. It's easiest if I list them now. So for 4, it's 2 times 2. For 15, 5 times 3. And for 18, 2 times 3 times 3. Now again, what I'm going to do is look for each number in the row that it occurs the most often. So I see that there are 2 2's in 4 and only 1 2 in 18, so I'm going to circle the 2 2's from the 4. And I see there's 1 3 in 15, but there are 2 3's in 18, so I'll circle the 3's that are in 18. And then there is just 1 5 in 15, so I need to circle that one. The extra 3 here and the extra 2 here do not get included because I've already done the 2's and the 3's where they occurred most often. Now I need to multiply, find the product of those circled numbers. So I have 2 times 2 times 5 times 3 times 3. And when I find the product of those 5 numbers, I will find the least common multiple of 4, 15, and 18. 2 times 2 is 4, and 4 times 5 is 20, and 20 times 3 is 60, and 60 times 3 is 180. The least common multiple of 4, 15, and 18 is 180. Example 4, real-life application. A traffic light changes every 30 seconds. Another traffic light changes every 40 seconds. Both lights just changed. After how many minutes will both lights change at the same time again? This is another least common multiple problem, and since we did the factor trees for our last example, let's do multiple lists this time. Working with 30. 30 times 1 is 30. 30 times 2 is 60. 30 times 3 is 90. 30 times 4 is 120. 30 times 5 is 150. And the list would go on and on and on. Let's see when I do 40 if we come up with a match. 40 times 1 is 40. 40 times 2 is 80. 40 times 3 is 120. 40 times 4 is 160. And I see I already have a match, so I don't need to go any further. They both have a 120. That would be the least common multiple. One more step though, this is 120 seconds when the lights would change again simultaneously. But the question asks us for minutes. So we need to put our answer into minute form. We know that there are 60 seconds in 1 minute. And we have 120 seconds, which is double, so we just need to double this. So that would be 2 minutes. In 2 minutes, both traffic lights will change again at the same time. 120 seconds or 2 minutes is the least common multiple for 30 seconds and 40 seconds.